लाईफ शांति का लाईफ नहीं होगी तो चार्ट में दाखला है ना ये चीज़ें कि आंकड़े ना अगस्त में इनकी पूछी बड़े लोग उनकी जवाब देते ये चार्ट में आइटम चार्ट में देखते अब पता नहीं अभी तो बहुत अनपेक्टिव अभी लाइफ स्टाइल में तो 10,000 का नौकरी भी नहीं किया अभी 10,000 का नौकरी भी नहीं किया आगे इतना बड़े लोगों को चेतन अगर कुछ अच्छी होगा उसके अंदर तो आप लोग नहीं अपने मर्द की नहीं पूछो मैंने अगर 15 से 10 से 15 लोग पूछे 10 में से एक आधी 10 तक कि नहीं बकवास चाट के बाकी दौड़ में थे आंकड़ा बहुत बकवास
In this question, we are given a product and we are asked to find out the sum of all the integer values of x such that modulus of x is less than 10, which satisfy the following inequality. If modulus of x is less than 10, what are the integer values that x can take? X can be either -9 or -8 or ... till -1, or it can be 0, or it can be 1 or 2 or 3 or ... till 9. These are all the integral values that we are looking at. Out of this, we first have to ensure that the denominator is not equal to 0. Because if the denominator is equal to 0, the expression itself is not defined. What are the roots of x cube plus 4x square minus x minus 4? To calculate the factors of a cubic equation, it is important to first calculate the first number, which is a root. So if you substitute the value of x to be equal to 1, the value of the denominator, if x is equal to 1, will become equal to 1 plus 4 minus 1 minus 4, which is equal to 0. Therefore, one of the roots of the cubic equation, which is in the denominator, is x minus 1. So now let us try to factorize the denominator. The denominator will become equal to x cube minus x square plus 5x square minus 5x plus 4x minus 4. We are writing this way because we want to take x minus 1 common. So now it is equal to x square into x minus 1 plus 5x into x minus 1 plus 4 into x minus 1. Or if you take x minus 1 common, this is equal to x square plus 5x plus 4. We know how to factorize a quadratic equation. So this is going to equal x minus 1 into x plus 1 into x plus 4. So x cannot be equal to -4 or -1 or 1 because they are the three roots of the denominator. Now let us try to factorize the numerator. The numerator is x cube plus 2x square minus x minus 2. That is the first term of the numerator. Again, if you substitute the value of x to be equal to 1, the first term of the expression will become equal to 1 plus 2 minus 1 minus 2, which is equal to 0. So x minus 1 is also a factor of the first term of the numerator. If you are trying to factorize it, x cube plus 2x square minus x minus 2 can be written as x cube minus x square plus 3x square minus 3x plus 2x minus 2. Or this can be factorized to equal x minus 1 into x square plus 3x plus 2. Or this is equal to x minus 1 into x plus 1 into x plus 2. That is the first term of the numerator. The second term, if you are substituting the value of x to be equal to 1, you will notice that we are not getting a 0. Because if you substitute the value of x to be equal to 1, x cube will be 1, minus x square is again 1, but minus 17x is minus 17 minus 15. So the value of the second term becomes equal to minus 32, which is not equal to 0. This would imply that x minus 1 is not a factor of the second term. How do we find the factor? The next thing to do logically is to substitute the value of x to be equal to minus 1. If you substitute the value of x to be equal to minus 1, x cube will become equal to minus 1, minus x square is again equal to minus 1, minus 17x will become equal to plus 17 minus 15. This is equal to 0. So we know that x plus 1 will be a factor of the second term. So now let us try to factorize it accordingly. X cube minus x square minus 17x minus 15 can be written as x cube plus x square minus 2x square minus 2x minus 15x minus 15. This is equal to x plus 1 into x square minus 2x minus 15. This is equal to x plus 1 into x minus 5 into x plus 3. Now if you are multiplying this term and dividing it by this term, you can cancel some common terms. You can, for example, cancel x plus 1 in the numerator and denominator. You can cancel x minus 1 in the numerator and denominator. So the expression will be simplified to equal x plus 3 into x plus 2 into x plus 1 into x minus 5 divided by x plus 4. This you want it to be greater than or equal to 0. Now let us multiply the left hand side and right hand side with x plus 4 whole square, because we want to remove the denominator on the left hand side. So you essentially want x plus 4 into x plus 3 into x plus 2 into x plus 1 into x minus 5 to be greater than or equal to 0. What are the roots of this polynomial, which is a power of 5? The roots are minus 4, minus 3, minus 2, minus 1 and 5. So let us draw the number series. It will look something like this. On this, let us plot minus 4. This is minus 4, this is minus 3, this is minus 2, this is minus 1 and this is 5. At all of these points, let us first understand the value of the expression. This is minus 4, this is minus 3, this is minus 2, this is minus 1 and this is 5. At 5, the value is equal to 0, because 5 is a root. At minus 1, the expression is not defined. At minus 2, again the value is equal to 0. At minus 3, the value is equal to 0. At minus 4, again it is not defined, because we know that x cannot equal minus 4 or minus 1 or 1. Next, let us assume that x is greater than 5. If x is greater than 5, all of these 5 terms will be positive. So the overall product will be positive. If x lies between minus 1 and 5, 4 terms will be positive. They are x plus 4, x plus 3, x plus 2 and x plus 1. They will be positive if x is lying between minus 1 and 5. But x minus 5 will be negative. So the overall product will be negative. And positive and negative keep on alternating. Similarly, over here you will get positive, here you will get negative, here you will get positive. And finally, if x is less than minus 4, all the 5 terms will be negative. So the product of 5 terms will again be negative. Now what are the integers for which the given expression is greater than or equal to 0? The integers are between minus 4 and minus 3, we have to add minus 3. We shouldn't add minus 4 because it is not defined there. At minus 2, again it is equal to 0. So we'll have to add minus 2. At minus 1, it is not defined. At 0, 1, 2 and 3 and 4, it is negative. In fact, it is not defined at 1, but at the other places it is negative, so we shouldn't count them. At 5, it is equal to 0, so we'll add 5. 6 also it is positive, because for all the integers greater than 5, this expression is positive. Plus 7, plus 8, plus 9. Remember that x has to be less than 10. So what is the sum of all of them? Minus 3 minus 2 plus 5 is equal to 0. The sum of 6 plus 9 plus 7 plus 8 is equal to 15 plus 15, which is equal to 30. So the required answer for this question is 30. Remember what we have done. The first thing to do is to ensure that the denominator is not equal to 0. Then factorize the numerator and denominator, cancel the terms which are common, then draw the number series. Once you draw the number series, identify the intervals for which the inequality is true, and then ensure that you don't make any mistakes by including either minus 4 or minus 1 or 1 in the final answer. In this case, the sum is equal to 30.
तो